Okay, this one's a bit of an adventure, but it's just an adventure in the setup. Once we get the setup together, it's not as difficult for the solver settings. Obviously, like the solver settings on the last one weren't really that difficult, but this one is. It also says solver settings if used must be saved. You actually don't need solver settings on this because you are using random numbers to create a Monte Carlo simulation. Okay. Now note here that it says do not fix your random numbers. That does mean that every time you open and close or save or do stuff with this, your random numbers are going to refresh. So your numbers are going to change ever so slightly. So just be aware that that is a feature, not a bug. Okay, your stuff will in fact change just a little bit, and so just don't worry about it. Okay, so it says here you want to calculate the profit. It gives you a formula here. That is a good thing to note, that we're going to be using that formula at some point. So you're obviously going to need a column that's going to use that formula at some point. We're going to have sales can be approximated by normal random variable with the mean and standard deviation given below, which are these two. Also, past fixed cost information is given. That's here. Using the Monte Carlo simulation with 30,000 repetitions, estimate the probability that you're going to incur a loss. That's here. I believe that's, yeah. So that's here. So this is going to be your probability right here. That's going to be the answer. Okay. So we have our trials here. We need at least 4 more columns. Now, if we look at what you've told us, we've got, we need to have a normal random variable. Okay. So let's put that one in, our random variable. We need to approximate sales, because look here, we have profit, sales, and fixed cost. So we have a random variable, and then we're going to need sales, fixed cost, and profit. And those are the 4 columns that he suggests. So let's do sales, let's do fixed cost, because I can spell, and then profit. Okay. And so the first thing we're going to do is these random variables. Now, if you've seen how to do it, you just go random variable generates a number greater than or equal to 0 and less than 1, evenly distributed, changes on recalculation. So it's going to change all the time. And then all you need to do is just close it. That's how you just tell it to create a random variable. So I hit enter, random variable. So if I hit, and then I want to just double click, see how it changed. So my random variable, whenever I fuss with it, is going to change. So now I'm not going to scroll all the way down, but you just double click on the corner and it'll do your 30,000 calculations all the way down in perpetuity. Okay, so you don't have to worry about it. Now, the next thing we need to do is figure out our sales. And for sales, we're going to use norm.inv. We need the inverse of the normal cumulative distribution, because we're estimating our sales. Sales can be approximated by a normal random variable with the mean and standard deviation given below. That's how you know you're going to use it's going to be a normal distribution, but we're going to do the inverse of the normal distribution. Okay, so norm inv. Okay, I'm sorry. This is an old one. Norm.inv is the correct one. And then here you see they want the probability, the mean, and the standard deviation. Our probability is our random number, because remember that random gives you a random number between 0 and 1. That's perfect for probabilities. So this is an absolute random probability. And then I want to multiply it by the mean, which they've given us. Hit F4 so you can copy it down. And the standard deviation that they've given us, hit F4 so you can copy it down. And that's it. So now our sales is going to be an inverse normal distribution with this probability, this mean, and this standard deviation. And there is our sales number. Notice random changed again, okay? And so these are our randomized possible sales for the month. We don't know what they are, but with this mean and standard deviation, that means that what is it, 67% of the numbers that it gives us are going to be, you know, plus or minus 5,000, and like 97% of the numbers are going to be plus or minus 10,000. Okay, so then we're going to double click, do it all the way down. So now we have our randomized sales figures. Okay, we also need to figure out what our fixed costs are. Now, over here, this is our fixed cost model and our fixed cost probabilities. And what we're going to do basically is we're going to use these same probabilities that we used to estimate our sales to estimate our fixed costs, which basically telling you that it's going to look up in this table the fixed cost that is between this number and or I'm sorry, given the probability of, is it the sales? Hold on, let me look up real quick. We're going to look up this number in here, and it's going to give us this fixed cost. Okay, and that's what we're going to do. Okay, so you don't like have to have extra numbers. I personally just used like this, but the way that he has it in his solution, what you can also do is make these true ranges where you can have this one. I'm sorry, hold on. That's dot equals L9. Hold on. Let me just look at this real quick. Oh, okay, I'm sorry. What he actually did was for this threshold here, this actually equals that. This should be like the probabilities. Oh, no, I'm sorry. Hold on. Don't mind me. I'm being weird. Okay, so you started off with this one. This one was already here. These three are going to be calculation cells. And if you look, sorry, like his is a little bit weird. There's no need to use array formulas. See how it says that? And so, what that says? Where is it? There's no need to use array formulas here. So basically what we need to do for this threshold here is that this equals this, but this one equals this plus this, which means that because this has a 2% probability, over 2% probability, it's going to be this, 60% of them are going to be, 9,000 or less. And then this is going to equal this plus this. Okay. And so this is basically kind of creating a range where from 0 to 2 is going to be this, from 2 to 4 is going to be that, from 6 well, not actually 6 to 3, but it goes down, but like 60% of the stuff is going to be here, and then 90% of the stuff is going to be lower than this. Okay, it doesn't make a super ton of sense, but it'll make sense in a minute when I do this stuff. or not. I gotta tell you, I don't 100% remember why this is here, but I'm sure it'll come back to me. So over here, we're gonna use the VLOOKUP. And so see, he says we don't need any array formulas, and I don't know why. I guess he says we don't need any array formulas over here, because you use the array formulas over here. So we're gonna VLOOKUP. We want the lookup value to be, I want you to look up this, and I want you to look it up in the table, and the table is actually gonna be this side, I believe. Is it this side? Because I've got J and K and not L. So I'm actually going to use this side instead of this side, because the problem is that with these probabilities, this gives me the probabilities, but this puts them into a range. So like if, for example, for this one where it has a probability of 1, it would basically put everything, it would under, or it would overdo this. And also this only goes up to 0.4, right? So because this only goes up to 0.4, everything over 0.4 would get 8,000 instead of getting, 10,000, which is what it's supposed to be getting. So that's why you sort of had to convert the probability into thresholds for where the fixed cost flips over to the next thing. Okay. So we basically needed to turn it into a between 0 and 1, as opposed to this, which is from 0.1 to 0.4. Okay, so that's why we did that. And then we're gonna make these F4 so we can drag these down, because I'm not repeating that 30,000 times because that's insane. Okay. And then, but the that's our array. And then our index column number is going to be number 2, because we wanted to return the fixed cost in this column. So we're going to do 2, and then we're going to close it. Okay. And you can see here, it's giving me a fixed cost. This is 0.6. It's given me 9 because 0.6 is closest to that, without going over. Okay. And then we can just watch, you're going to watch it change again. And double click. It's still that, but you see here, 0.14 is between 0 and 2, so it's given me 7. 0.05, same thing. 0.57 is between 2 and 6, so you can kind of see this one, 0.95 is over 9. So you can see how we've now got those numbers. Okay, now we just need our profit, which right here, now we use this profit formula that it gave us at the top. Okay, so then we're going to equal 0.3 times sales minus fixed cost. And that's it. There's our profit. We can double click that one as well, put it all the way down. Okay. And so now we have all of this stuff. We need to create a probability. So the probability over here is basically going to be the random numbers can't go less than 0. Sorry, hold on. I'm just looking here at this profit probability thing. It says count if the range in E is greater than. So we need to figure out the probability that we're going to incur a loss. A loss is any time our profit is less than 0. So anytime our profit is negative. Oh, here's one. See, here's a couple down here. And that's just where our, because we're taking 1/3 of our sales minus our fixed costs. So there's absolutely points where 1/3 of the sales is going to be greater than the fixed cost, just based on the probability numbers. So you can see here, this one is negative, and this one is negative, and this one is negative. So in order to figure out our probability of incurring a loss, we need to count every time our profit is less than 0 divided by the total count of all of our permutations. Now we know that all of our permutations are 30,000, but we can't just put in 30,000, right? We're not allowed to hard code that in. So instead, what we're going to have to do is we're going to equal COUNTIF, and the range is just, we're going to do E. And the easiest way to do this without driving yourself crazy, because it's 30,000 cells, is E:E, and that's just that whole column. And because it'll ignore the words, and it'll just do the numbers, so we don't have to worry about the fact that these titles and stuff are in here. You can just ignore that. So this is going to be our range. Then we're going to, what do we want it to look for? We're going to use the quotation marks, and we want it to be less than 0 because we want it to be a loss. And remember, 0 is not a loss. 0 is breaking even. Ideally, if you min-max everything and you break even, great. You know, that's totally fine. But we want to find out when it's a loss. Okay, so we're going to count if it's a loss. And then we want to divide that by, and here we can just count the whole column. We can just count. We can just count the whole column. Because if we go back to count, see how it says counts values? It only counts numbers. If we wanted to count things other than numbers, it's like count A, where it will count like cells that don't have numbers, but count only counts numbers, if you remember from like our first homework. Okay, so we're gonna hit enter, and here's our probability. Okay, we could even make it a percentage if we really wanted to, but I'm not gonna. But our probability of incurring a loss is like 6.4%. Okay, and so all we did here was we generated random numbers. We figured out a random sales number based on an inverse normal distribution. Now you ask, what happens if we do a normal distribution? I actually don't know. Let's see what happens if we just do a normal distribution. And we go dist. Normal distribution. What happens then? I've entered too few arguments for this function. Ah, see? Because then we would need an x, we would need a mean. We'd have to start with an x. For a normal distribution, you'd have to start with an x. We'd need a mean, we need a standard deviation, and we need a cumulative something or other. So we don't have all of those variables. We only have a mean and standard deviation. So if I go back and change this back to inv, norm.inv, this one only needs a probability, a mean, and a standard deviation, and those are the 3 variables that we have. So that's why we use norm.if. Okay, and that's this whole problem. Okay, I hope this helps.